Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about statistical properties of random process. And what are the statistical properties? Mean of a random variable, variance of a random variable, movement of a random variable, etc. So these are the statistical properties of a random variable. The statistical averages mostly used in description of a random process are the mean function, autocorrelation function, and cross correlation function. First, I am going to discuss about mean of a random process. The mean value of the random process x of t is equal to the expected value of the random process x of t, and it is given by or defined as expectation of x of t. That expectation of x of t is the mean value of the random process x of t, and it is also denoted as x of t bar, so which is equal to, in continuous case, integral minus infinity to infinity x into fx of x comma t dx, where fx of x comma t is the density function of the random process x of t, density function of the random process x of t. So expectation of x of t is also called the ensemble average of x of t. Expectation of x of t is also called as ensemble average of x of t. So this is the mean value of the random process. That is the first property of the statistical properties of the random process. And the second one is autocorrelation function of the random process. Consider a single random process x of t. In that single random process x of t, x1 and x2 are two random variables. The two random variables be defined at the two time instants t1 and t2, with their joint density function is fx of x1 comma x2 comma, and the time instants of the random variables x1 and x2 are t1 comma t2. The correlation of x1 and x2 is expectation of x1, x2. So this is already discussed in previous chapter. The correlation function of the random variables already discussed in previous chapter. So now here the random variable x1 is equal x of t1 and the random variable x2 is equal x of t2. So the correlation of the random variables x1 and x2 is expectation of x1, x2 is equal expectation of x of t1 into x of t2. So this expectation of x of t1, x of t2 is called the autocorrelation function of the random process x of t, and it is denoted as the autocorrelation function of the random process x of t is denoted as rx of t1 comma t2 or r suffix xx of t1 comma t2. Simply rx of t1 comma t2 or rxx of t1 comma t2. So, and it is given by mathematically rxx of t1 comma t2 is equal expectation of x of t1 into x of t2. So for continuous case, the autocorrelation function of the random process is rxx of t1 comma t2 is equal expectation of x1 x2, which is equal to integral minus infinity to infinity, integral minus infinity to infinity, x1, x2, joint probability density function of the random process x of t into dx1, dx2. So this is the second property of the statistical property of the random process. Next, third one is cross correlation function. And previous we have discussed about autocorrelation function. In that autocorrelation function, consider single random process x of t. In that single random process x of t, consider two random variables x1 and x2 at the time instant t1 and t2. So now here we are going to discuss about cross correlation. In this cross correlation, we have to consider two random process. The two random process are x of t and y of t. The two random process x of t and y of t defined with the random variables capital X and capital Y at the time instants t1 and t2. The joint density function is the joint density function of the random process x of t and y of t is f x y of x comma y at the time instance t1 comma t2. Then the cross correlation function of the random variables x and y is expectation of xy. So now here the random variable x is equal to x of t1 and the random variable y is equal to y of t2. So the correlation function of x and y is expectation of xy is equal expectation of x of t1 into y of t2. So that expectation of x of t1 into y of t2 is called the cross correlation function of the random process x of t and y of t. The cross correlation function of the random process x of t and y of t is denoted as r suffix xy of t1 comma t2, which is equal to, and it is given by mathematically rxy of t1 comma t2 is equal expectation of x of t1 y of t2 is equal expectation of xy. So for continuous case, and it is given by integral minus infinity to infinity integral minus infinity to infinity xy into joint probability density function of the random process x of t and y of t into dx dy. So these are the three important properties of statistical properties of a random process. So that are mean of the random process, autocorrelation function of the random process, and cross correlation function of the random process x of t and y of t.